Did aliens create us? The Panspermia mystery. For centuries, humanity has grappled with the profound question of our origins. We've sought answers in ancient myths, religious texts, and increasingly in the rigorous pursuit of science. Yet, what if the conventional story of life's genesis on Earth is incomplete, or even entirely mistaken? What if the spark of life didn't ignite here at all, but traveled across the vast cosmic ocean? This radical notion forms the core of a truly mind-bending concept, the panspermia theory. It challenges our most fundamental assumptions about where we come from. Panspermia, at its heart, suggests that life did not originate on Earth. Instead, it posits that life, or at least its essential building blocks, first emerged elsewhere in the universe. From there, it journeyed through space, eventually finding a home on our nascent planet. Imagine life hitchhiking across the cosmos. These potential cosmic carriers could be anything from resilient microorganisms embedded within comets and asteroids, to even more speculative possibilities like advanced alien vessels. The universe, in this view, becomes a vast interconnected web of biological exchange. The implications of panspermia are nothing short of staggering. If life truly arrived from beyond our world, then humanity's true identity takes on an entirely new dimension. We might not be Earthlings in the strictest sense, but rather descendants of cosmic travelers, making us, in a profound way, aliens ourselves. Let's rewind the cosmic clock to Earth's tumultuous beginnings. Our planet coalesced from a swirling disk of dust and gas approximately 4.5 billion years ago, a fiery, inhospitable world. It was a place of intense volcanic activity and constant bombardment from space. Slowly, over hundreds of millions of years, Earth began to cool. Evidence suggests that liquid oceans, crucial for life as we know it, appeared remarkably early, around 4.3 billion years ago. This was still a violent epoch, but conditions were gradually becoming more stable. Then something extraordinary happened. Fossil evidence indicates that life in the form of simple microbial organisms was already present on Earth a mere 3.8 billion years ago. This timeline presents an incredibly fast emergence, a blink of an eye in geological terms. This rapid appearance of life poses a significant scientific puzzle. How could such complex biological processes arise so quickly on a young, still recovering planet? The window for abiogenesis, the spontaneous generation of life from non-living matter, seems incredibly narrow. Scientists grapple with the sheer complexity required for life to spontaneously assemble. How did intricate molecules capable of self-replication and metabolism form so early and efficiently from a primordial soup? The odds seem astronomically low for such a swift development. This leads to a radical possibility, one that panspermia directly addresses. What if life's essential ingredients, or even fully formed primitive life, did not originate on Earth at all? What if the conditions here were simply right for it to take root and flourish? The suggestion is compelling. Perhaps these vital ingredients, or even the first simple organisms, arrived pre-packaged from space. This would dramatically shorten the timeline required for life to appear on Earth, shifting the origin story to a cosmic stage. The idea of life originating elsewhere might seem far-fetched, but modern astronomy and astrobiology offer intriguing clues. We now know that space is not an empty void, but a rich chemical environment. It teems with organic molecules, the very fundamental components of life. NASA missions have provided compelling evidence for this cosmic abundance. Analysis of meteorites that have fallen to Earth has revealed the presence of amino acids, the crucial building blocks of proteins. These are not terrestrial contaminants, but extraterrestrial in origin. Further observations have deepened this understanding. Complex sugars, which serve as the fuel of life and components of genetic material, have been detected on comets. These icy wanderers are essentially cosmic snowballs, preserving ancient material from the solar system's formation. Beyond our solar system, astronomers have made astonishing discoveries. Vast clouds of alcohol and water, along with other complex organic molecules, have been observed between stars. These interstellar nurseries are fertile grounds for chemical reactions, hinting at widespread prebiotic chemistry. Even more tantalizing are hints of resilience found within these cosmic travelers. Some meteorites have been found to contain microscopic structures that bear a striking resemblance to fossilized bacteria. While highly debated, these findings fuel the imagination. This leads us to a core principle of panspermia. If life can form elsewhere, it must also be able to spread. The theory posits that life can indeed travel interplanetarily, or even interstellar, provided it possesses the incredible resilience to survive the harsh journey through space. For panspermia to be a viable theory, a critical question must be answered. Can life truly survive the unimaginable harshness of space? The vacuum, the extreme temperatures, and the relentless radiation seem insurmountable obstacles for any organism. Remarkably, the answer appears to be a resounding affirmative, thanks to discoveries made right here on Earth. Scientists have uncovered a diverse array of organisms known as extremophiles, life forms that thrive in environments once thought utterly incompatible with biology. These extremophiles demonstrate an astonishing range of survival capabilities. They flourish in conditions of extreme heat, such as hydrothermal vents at the bottom of the ocean, or endure crushing pressures deep within the Earth's crust. Others survive in freezing cold or tolerate incredibly high levels of radiation. Perhaps the most famous and compelling example is the tardigrade, often called a water bear. These microscopic invertebrates are virtually indestructible. They can survive being frozen solid, boiled, dehydrated for years, and most astonishingly, they have been shown to survive exposure to the vacuum and radiation of outer space. This incredible resilience provides a theoretical pathway for panspermia. Imagine resilient organisms, perhaps in a dormant state, embedded within rocks ejected from a planetary impact. These seeds could then travel through space, shielded from radiation and vacuum until they encounter another habitable world. Such ejected rocks, propelled by asteroid impacts, could carry life from one planet to another within a solar system. Over vast stretches of time and with enough cosmic collisions, this mechanism could potentially even facilitate interstellar travel for hardy microorganisms. The conclusion drawn from studying extremophils is profound. Life might not just survive the rigors of space, but in some cases, it might even be uniquely adapted to it. The universe, far from being a sterile void, could be a cosmic highway for life. While the concept of life naturally spreading through space is compelling, there's an even more audacious and controversial extension of panspermia. This is the concept of directed panspermia, which takes the idea of cosmic origins to an entirely new level. Directed panspermia proposes that life on Earth was not merely a random cosmic accident. Instead, it suggests that life was intentionally sent to our planet by an advanced extraterrestrial civilization. It implies a deliberate act of seeding. One of the most prominent proponents of this extraordinary idea was none other than Francis Crick, the Nobel Prize-winning scientist who, along with James Watson, co-discovered the structure of DNA. His scientific credentials lent significant weight to the speculative theory. Crick's rationale stemmed from the sheer complexity of DNA and the rapid appearance of life on early Earth. He argued that the intricate machinery of life, as encoded in DNA, seemed too sophisticated to have arisen spontaneously and so quickly from the chaotic conditions of our young planet. Crick's hypothesis suggested that life was seeded on Earth, perhaps as a deliberate experiment by an alien intelligence. Alternatively, it could have been an act of species preservation, a way to ensure the continuation of life from a dying homeworld. The profound implication of directed panspermia is truly staggering. If this theory holds true, then all life on Earth, including humanity, could be the direct descendant of an ancient, advanced alien civilization. We might be the last remnant of an extinct alien world, a living legacy sent across the stars.